everyone! So today we're going to be talking about adding and subtracting mixed numbers. So we've talked about adding just regular fractions, and we know already about adding and subtracting whole numbers. So today is just going to be a review about adding and subtracting mixed numbers. So when we have a problem like this, 4 2/3 plus 2 1/3, the best thing, easiest way I think, is to separate them out in your mind. 4 2/3 is the same as having 4 plus 2/3, and 2 1/3 is the same thing. So we could add our whole numbers separately. 4 plus 2 would be 6. And then our fractions separately, where when they have the same denominator, we know we just add the numerator. So we've got 2/3 plus 1/3 equals 1, 2, 3, 3/3. So our answer could be 6 3/3, but I know many of you are already looking at this and knowing that when you have a 3 on your numerator and 3 on the bottom, when they match your numerators and denominators, we call that a whole fraction. So this 3/3 would be equal to 1 more whole. So it would be equal to 6 plus 1 more whole. So our answer is actually 7 simplified. If you wrote 6 3/3, you would not be wrong. You would be mathematically correct. But a lot of times on quizzes and things, we might be asking you to simplify, and so that would get you to 7. So let's look at another example of adding and subtracting mixed numbers. Here we have 6 1/7 plus 3 3/7. I know I can add 6 and 3 easily. 6 plus 3 makes 9. 6, 7, 8, 9. And then I've got 1/7 plus 3/7 would get me to 4/7. And there isn't a way to simplify this fraction anymore because 7 is not divisible by 4. So this would be our final answer here. We would not need to simplify. Okay, so next we're going to talk about fractions when we add them if they have unlike denominators. So right off the bat, I'm noticing that one of the fractions has 1/8 and one of the fractions has 1/2. I can use my knowledge of equivalent fractions to find a fraction equivalent to 1/2 that would have the same denominator as 8. So my fraction would change from 3 1/8 plus 1 1/2 to 3 1/8 plus 1 and something over 8. Well, to be equivalent to 1/2, I know that would be 4/8. So all I did was just change these mixed numbers here to an equivalent fraction. I haven't changed the value of the fraction, I just changed the amount of parts in the denominator so that it was an easy number for me to add. So now I can add 3 plus 1 is 4, and 1/8 plus 4/8 would be 5/8. This might not always be something you can do off the bat. If we look at our next example here, 4 2/3 plus 6 4/9. This might be more difficult to come off the top of your head to find an equivalent fraction to 2/3 that has 9 in the denominator, or vice versa. So what I'm going to do is a little trick based on what we talked about with finding equivalent fractions. So we want our 2/3 to have something in the denominator that matches this denominator, correct? We want our fraction to have a 9 in the denominator so that they're easier to add. Or we could have done vice versa, finding them having something in the same realm of 3. Meaning we're trying to find a common denominator. We're trying to find them both to have a denominator in common. We call this a common denominator. So in order to find that, I know that I go from left to right, and it increased from 3 to 9. what multiplication fact would get me from 3 to 9? 3 times 3 equals 9. So now I find my equation up top. 2 times 3 equals 6. So now I've just found an equivalent fraction to 2/3 so that I can change my addition fact to be 4 6/9 instead of 2/3 plus 6 4/9. Now I can add these together because they have like denominators. So 6 and 4 would be 10, and then 6 plus 4 more would be 10 again. Now, looking at this answer, we're noticing that we have an improper fraction. So we're just trying to see how many groups of 9 we can pull out of 10/9 like we've talked about in past videos. Right? So 10/9 is the same as having 9/9 plus 1 more 9. So I've just pulled out 1 whole and 1 9. So my answer is 10 plus 1 whole plus 1 9. So my answer would be 11 and 1 9. Simplified. Let's look at another example of that, especially starting with using our equivalent fraction strategy, right? So we've got 5 3/8 plus 2 3/4. I could try noticing that 8 and 4, 8 is divisible by 4. I could try and make them so that both of the fractions have a common denominator of 4 instead of 8. So let's see what that would look like to find a denominator of 4 that's equivalent to 3/8. Right? Because I want to change 3/8 to something that has a denominator of 4. So from left to right, it's decreasing, which tells me that I'm going to divide. 8 divided by what gets me to 4? 8 divided by 2 equals 4. So then I have to think, oh, can I do 3 divided by 2? That wouldn't get me an even number. So even though I thought I could get somewhere with the denominator, the numerator wasn't going to get me anywhere. So I have to resort to making the denominators both have an 8, because we can always multiply, we can't always divide. So now I'm going to change 3/4 to have a common denominator of 8. So 4 times 2 equals 8, 3 times 2 equals 6. So notice how we can always multiply a number, we can't always divide it evenly without having remainders left over. We don't want any more remainders today. We want it to be even so that we can evenly add this. So now I've just changed 3/4 to 6/8. So now my new problem is 5 3/8 plus 2 6/8. And now I can add that. 5 and 2 makes 7. 6 and 3 makes 9/8. And I can simplify 7 and 9/8 because I can pull one group of 8/8 out to give me one extra whole to have 8 wholes in total. And 9, take away that 8, would leave me with 1/8. Alright guys, the next skill we're going to talk about is subtraction of mixed numbers. So in best case scenario, you've got common denominators and the fraction in your first number is bigger than your second number, so it's really easy to subtract. If I were to stack these up like standard algorithm style, then I know I could subtract 5/8 minus 3/8, which would get me 2/8, and 6 minus 4 would give me 2. So my answer would be 2 2/8. Now I can do that with several different types of subtraction problems. But what happens when you get to a problem like this, where the numerator in your first number is smaller than your second number, right? So when you stack it, 6 1/8 minus 4 3/8. Question is, what do I do now? Well, if I was subtracting whole numbers, not fractions, I would know I would have to borrow from the next place value over. You can do the same in these situations. So, in this case, I have 1/8 and I want to borrow a whole from the whole numbers. So, I know that if I take one whole away from 6, that would leave me with 5. If I gave one whole to the fraction, all I would have to do was rewrite that in fraction form as 8/8 with that common denominator of 8. So now what I'm looking at is 8/8 plus 1/8 would give me 9/8. So now 1/8 has become 9/8. All I did was take a whole from the whole number section and give it to my fraction. So now I can subtract 9/8 minus 3/8, which would leave me with 6/8, and now I can subtract 5 minus 4, which would give me 1. So now my answer is 1 6/8. I'm going to show you a few more examples of that. 4 2/8 minus 2 5/8. If I stack them up standard algorithm style, I know I can't take 5 away from 2 in my fraction section, so I'm going to borrow one whole from my whole number, which would make that 3. So in this case, 8 is the common denominator again, so I'm giving the 2/8 one whole in the form of a whole fraction, 8/8. 8/8 plus those two extra 2/8 would give me 10/8 in all. So now my 2/8 has become 10/8. Now 10 minus 5 would give me 5/8. 3 minus 2 is 1. There's my answer. We're going to show you one more. 7 1/7. Take away 3 3/7. If I stack that standard algorithm style, looks like this. I know I can't take 3 away from 1, so I'm going to borrow one whole. That would leave me with 6. If I give one whole to the 1/7, that would look like this. I'd be giving 7/7. If I add my extra 1/7 to the 7/7, then that would leave me with 8/7. So now 1/7 becomes 8/7. 8 minus 3 would be 5/7. 6 minus 3 would be 3. Here is my answer. I'm happy to show you more examples of these in office hours and many other different things we've talked about today or in the past. I can't wait to see you. Bye-bye.